Okay, boys and girls, let's do a marathon. So I have an interview coming up that's 3 rounds of 45 minutes, 2 hardware interview, 1 software interview. So let's just um, do a longer practice of 3 rounds of 45 minutes in a row to exercise the stamina. Um, so unlike other interviews, for this specific company, there's zero rest in between. So a lot of times in interview situation, you have maybe a 5 minute break between interviewers. But in this specific case, when they say like you have like a back-to-back technical interview, it's just like one contiguous slot. Like right as soon as you finish one question, they just slam another one at you. So there is like zero breaks at all. So that makes it particularly challenging as you know compared to other stuff, because even like 2 minutes of your brain kind of relaxing lets you clean slate everything and then just restart. But doing it 45-minute rounds by three, you really need to be able to internally be able to clean slate and reset your brain if there's anything that's throwing you off, or if you just need a break. Just take, like it's your, like you need to be able to autonomously, like within a few seconds or a minute, be able to kind of cleanse your brain and restart, so you can have clear thinking with because if you don't have clarity in your thinking, it makes these already difficult problems fairly impossible. So anyway, let's start the first round, and then right after the first round, I'll know 45 minutes is up, and then I'll just keep working a second round of hardware, and then I'm gonna do a third round of um, software. Let me actually prep the software problem like this, and then shortest common super sequence. That doesn't sound fun. Sounds like DP. So maybe actually I'll just do 90 minutes. And then after 90 minutes, I'll set this to 45. So I get like a 3-second break, and I'll start working on this. And then, yeah, let's see how it goes. Okay. So back to cellular automatons. The game is played 2D grid. Each cell is alive or dead, and each time step, each cell changes state. Determining changes state depending on how many neighbors it has. Okay. What's a toroid? Where the sides wrap around. Okay. For example, corner cell 00 has 8 neighbors. Oh wow, okay. This is quite interesting. That's pretty early in the COVID phase. Huh. I remember, anyway. I remember having to write a solver for this back in college in MATLAB. Anyway, the game is played on 2D grid, and 00 has basically 8 neighbors, so all combinations of I plus or minus 1, j plus or minus 1 at each time step each cell. So this spec is, again, quite vague and bad. So here it says at each time step, each cell changes state depending on how many neighbors it has. So I'm assuming how many neighbors it has that are ones. This game is forming on infinite grid. Yeah, so I think like that's the thing, right? Because then every single cell has 8 neighbors. Doesn't it? Yeah. So I'm guessing this is a pop count of your neighbors. Because otherwise, all cells have 8 neighbors, and then so you just assign q to 0 and you're done. So I don't think this is assigned q to 0. All right, so let's maybe start from the base of the problem where we actually need to load the data into Q, and I guess they were pretty good about like synchronous load versus like non-synchronous stuff, but I guess now it's all assumed synchronous, but then this is bad spec, right? Because you can't, yeah, you can't really expect people to just know. So at work, you should be always very specific about what your requirements are. My Q two-dimensional, I guess, and then assign Q two-dimensional is just going to be Q. So then we have this. So 0 means 7 to 0, 1 means, 0 means 15 to 0, 1 means 13 to 16 of this Q. Else next Q this translates this 2D array back to a 1D array. Actually, let's just see if this compiles. I'm curious if I know I can do it like this, but I don't know if I can go back. Object D is not declared. Because once this boilerplate is good, then we just need to handle the looking at the neighbors, especially your corner case, and then going ahead and handling the pop count for the neighbors. So I mean, certainly will be like that. So, and yes, this is good because it's not all 0, so my understanding is somewhat correct. Right, so then this next Q2D is just a two-dimensional calculation of the next evolution, and then the next evolution we just pass it back and convert it back to a 1D array, and then we just pass it to Q, and then we output Q. Okay. I is less than 16. Is some function of Q of 2D. If I and j are both bigger than 0, it means that we're not on the So basically, I just want to do the common case for this one, and then I'll have if statements for the corner cases. There's always eight neighbors. So this is keeping the same I, and then this, let's do I minus 1j, I plus 1j. So this is like across, and then let's handle the x, which is q2d, I minus 1, j minus 1, q2d, I plus 1, I plus 1, and then q2d, I minus 1. J plus 1, and then q2d of I minus 1. No, I minus 1, j plus 1 is top right, and then so I plus 1, j minus 1 is that. So I need bottom left, which is j minus 1 and I plus 1. Perhaps I can just do something like this for my own double checking. I constant, j plus minus 1, j constant, this, and I wonder if there's a better way to do this. I was thinking maybe one could do like a 17 by 17 grid. So But then if you the 1 to 2D2 one is a mess for that. So the only way you like the most reasonable approach would be Q underscore 2D, and you massage that into a 17 by 17. But then if you do that, that's the same actually, because you need to handle all 4 boundaries. Is there a way to handle 2 boundaries at the same time so I don't need to write that much code? So this is like the base case. So like so like this only cares about if uh J is 0. So I know this is safe like here. I know like Hmm. I guess, yeah, I mean, there's probably some clever way of like doing like up, right, left, down shifts. Rotational shifts in the 2D array or something like that. Um, but let's just do it like this, where if I is less than this and j is more than this. No, there's too many combinations. Maybe like just table that here. Like if I have a 2D and I want to rotate shift. Then for each row, neighbor, top left, neighbor, top right, neighbor, right, neighbor, left, neighbor, bottom right, bottom left, neighbor, bottom right. So top left says, well, let's just do maybe top first. Top shoves the bottommost row to the topmost, and then everything is one after, meaning like So for example, last row 15 is gonna get row 14s, but then row 0 is gonna get row 15. I wonder if I can do that in the loop easily. Doing this 8 times is like really error prone, so I'm quite hesitant, but whatever. Actually, this doesn't save me anything, right? So just do it like this. So my bottom neighbor is just gonna be the I+1, right? So, and then likewise for my left and right neighbors. So actually this is different. Actually, why? let's do like so this is a right rotating shift, meaning then this would be just 15. And well, let's call it left eye for Jesus. Yeah, for left neighbor. Okay. Does that make sense? Actually, this is not left right, this is top bottom. But that's okay, it's doesn't matter. It's kind of just naming. So if it's like my right neighbor, but like vertical, then if I'm at the outermost edge on the right hand side, then my right neighbor is 0. Otherwise it's I plus 1. And then this condenses our cases to something a bit simpler, because then we can just work with these 4 variables to do a pop count. This intuitively makes sense because if I'm doing I minus 1 normally and I'm at 0, 0 goes to 15. And if I'm doing I plus 1, then I'm at 15, then I just roll back to 0. So same thing here for j, j minus 1, so 0 minus 1 is 15. And then if I'm doing right j is j plus 1, 15 rolls to 0. Now that I've defined these, and these are complete because these if-else implies no latches, right? One could condense this even more, but I won't do it here. It's just to say the default value is these. And then, for example, if j not 15, then we overwrite it, then we don't have to have like all these extra lines here. But anyway. So let's just do clockwise for easiness of thinking. Left eye means one before. Left J, left eye J, right. Left I J plus right J, and then 3 o'clock position will have I of right J, and then we would have right I, right J. And then we would have J and right I, and then right I, left J, and then we have the 9 o'clock position, which would begin also this, but then left J. This is top right, and then this is bottom left. Okay, so you know, hypothetically, I'll just say this. So this count says for any ij, we have this many neighbors. So count is like the number of neighbors, and count is the number of neighbors, and the rules are if count is 2, then next q to d I of j is just going to be q of 2d I of j, so nothing changes. And if it's 3, this shall be a 1. Else 0 actually, so why don't we just do so count is 3 is 1, else 0. And now we've updated our next q to d. The next q to d gets converted to next q, which goes to q. So let's try. This is probably formulating this is probably the harder part of the thing, but let's see. Because it's like a lot of things going on, so a lot of ways to, break. Okay, well, I guess even though it's like 69 lines of code, yeah, first try, so that's good. How much time did we take up? That is 45 minutes. All right. One input and one output. So if I'm at B, then go ahead and output 1. If I'm at A, then output 0. I don't really know what Moore versus Mealy state machine is. Is that bad? By its current state. All right, cool. What is the reset? Reset is B. I like using enums, but yeah, okay, whatever. And then the state transition logic says, if for case B, then first out is 1. I don't know if I can output reg this, or if I need to explicitly output reg this or not. If not, I'll just assign, out equals out equals state equals B. But for now, I think this is a little cleaner. So out is 1, and then the next transition is if input is 1, then we stay at B, otherwise we go to A, and likewise okay, they want me to do this. Okay, fine. This one I'll skip because the only different is there's no pause at reset, so this doesn't This is identical problem. I don't really want to study the same problem like twice. This is more state machine with two states. Put the state machine. Okay, so basically there's two inputs. So case of state and case, and if I'm at off, then next state is basically if not J and off, or J and on. I guess I don't really need begin end here, but whatever, I guess. K goes back to off. It's just on. That's identical again. Cap J, okay. A, B, C, D, okay. And implement only the state transition logic and output logic. Then should have no implied latch because state can only be one of these values. I see. This is an interesting way of doing it. In is 1 and state is 3, which is D, right? Then my output is 1, so that's good. And my next state is 3. Wait, what is it again? In 3. In and 3. 3 is D, right? So here should go to B. B is 1. So why does this say my next state is 3? Not sure what this is doing. In 3 means in and state is 3. So if it's in, then this gets masked out, and I see. Because this is more than 1 bit and in is 1 bit. So, all right. So anyway, for the next problem, it's quite interesting to have this approach to next state, because normally the boilerplate is like you have an always com block, always ff block, always ff block updates it, and always com block has like a case statement. This also works, but it's just interesting, I guess. I haven't really seen any like production code at any company where a state machine isn't like a case statement. Obviously this will work, but a case statement is like, I guess, easier to read. than a bunch of formulas. Because keep in mind, you're writing code not just to be functional. That's probably like 10% of it. 90% of it is like, can other people read your code? So anyway, next state of A happens if in is 0 and state is A or C. So next state B happens when in is 1 and think, yeah. And C happens very specifically when not in and state is C. Sorry, state is B. Or D. So same formula as this, except BD instead of AC. And then D happens the opposite. And out is when states D. Enum Verilog. God, quite annoying. Yeah, so I like using enum. Let's see if that compiles. But first, we need to deal with more bugs. So in and two. So in and B produces D. In and D produces B and outputs 1. Yeah, 2 is B, right? So in and B produces B, actually. What did I say? 8. Oh. Um. C in 2. Okay. Sorry, C produces 2. But they're expecting A. C is 1, 1, 0, 0. So it's like these two at the same time. And in is 1. Okay. So D and B should be asserted. So in and state equals C. Next state D is when in is 1 and state is C. C is just 4 plus 8, right? So then 4 and 8. 4. In and state equals 4. I see. Okay, I got it. Okay. So you can have multiple states at the same time, which was the bad assumption here. Actually, I guess what they're looking for is this. B. Can state be 0? Doesn't seem like it. If state can't be 0, I'll just say... Yeah, actually, I'll just do A, B, or D. I guess this sort of defeats the whole purpose of a one hot state machine, because the whole point of one hot state machine is that you can you only have, like, you map it to one state. Well, I guess that defeats the whole purpose of a state machine if you can be multiple states at the same time. And especially one hot state machines are more made for timing purposes. So I don't know, it just seems like if you have like 3 states at the same time, then it's very hard to handle the control logic. Anyway, so Inum says basically you don't have to care too much about like how many bits or otherwise. So next state equals A B C B A D C B. And asynchronous reset. And a reset is FSM to A. And in this case, you know, enum says A is 0, B is 1, C is 2, D is 3, I think, or the reverse. But the thing is, it doesn't matter because it's all abstracted away, right? You only care about how these names transfer to the next name based on the function of in. So this is kind of like the canonical way I would do it. But you can kind of see it doesn't make a lot of sense, like if we're in both B and D at the same time, right? Suppose B is a state where you do some set of actions, and then D is another set of controls where you do some set of actions. It's a lot easier to maintain if you make it mutually exclusive, because if you have like a production chip and you have 12 states and you can have, let's say, 5 choose 12 different states within 12 states, then it's extremely difficult to consume all the different combinations of logic. You might as well create 2 separate state machines that have some overlapping logic, and it's a lot easier to consume because you can say FSM A does this sort of thing, FSM B does this sort of thing, and then they can have some states that are like semi-overlapping, as opposed to like have one giant state machine that's like just a compilation of a bunch of different state machines together and then spitting out like 10 different states. Anyway, this is the same problem, so again, we'll skip it. Okay, this is the skipped one. The flow rate when the level is between upper and lower sensors. Below S of 1, FR should also be asserted. The table below, if the previous level was higher than the current level, the flow rate should be increased. Okay, just implement it. basically this is the base FSM, and then if it's this, you also do FR, and then if you're, you know, S2 in your previous S3 or your S1 previous S2 S3, then you also do FR. S3 you don't do FR because previous you have nothing. DFR. Oh, okay, this is supplemental. So, and active high synchronous reset. That does something. No sensors asserted, all 4 outputs asserted. Then if we can assume that these are the only possible states, so we can't do S1, comma S3. So then we can say if assign DFR if US is 0, or if US, which is the previous state. So let's say I clock something in this cycle, but then this one, like let's say all through is up, and then 3 to 1, it's all ones, and then next cycle it's 2 1. Then there's a cycle where this is 3 to 1 is all ones, and only this is 2 to 1 is 1, so then there's a delta there. So, or US 3 and not S3, or new S2 and not S2, or new S1 and not S1. Because this is a thermometer encoding, so when I go here to here, the rest of the bits don't matter. I really only care like, hey, I had S3, now I don't. Or I had S2, now I don't. I have S1, and now I don't. Basically, FR1 is when our S3 is not asserted. So anytime S3 is asserted is no F1. So So as soon as new S3 detects, so like our current state, it says S3, then we stop it. So first DFR is like one cycle later. If the previous level was lower than the current level, the nominal flow rate should take place. If the previous level was higher than the current level, the flow rate should be increased by opening the supplemental flow valve. In here, the previous, so this is lower than this is true, but then this is, the previous level is not lower than the, is not higher than the current one, right? It's equal. So what is this DFR saying? It's this DFR just saying that if I'm not increasing, so suppose I detect this, then I turn it on one cycle later. Yeah, this is like another spec thing because it seems like there's some clarity that's needed about the timing, like the exact cycle timing. Yeah, it's a lot better if like specs had timing diagrams so you kind of know exactly what they're talking about and you can map it to the words just via wave drum. I guess I still don't know what DFR is supposed to mean. If previous level was higher than current level, flow rate should be increased. I guess previous level meaning the last changed. Okay, so then, oh God. basically if I don't have an increase. So if it's like a previous level, like 7 to 3, I assert it all throughout 3. If it's like 3 to 1, I assert it all throughout 1. Same for 0. And then the only way this would ever reverse is like if I go from like 0 to 1 or 1 to 3. Suppose as you go to 0 to 1 here, the DFR ticks affect the next cycle. So when I detect this, or when I detect this, or when I detect this, I need it to go to 0 in the next cycle. So here that it's saying like there's new higher level underscore Q, and then I could just say so a new higher level would trigger this and then delay it by 1 cycle, which will turn this off. But I also need one to turn it on actually, which is so the delay works of turning it on. So this says set, and then this says hold. And this says clear. This clears the hold. And I guess in this case, this is redundant because this is a next cycle thing, and we won't have this and this at the same time because they're opposite cases. Let's see if this set, hold, clear works. Looks like it. All right, so that's that one. Sure, right equals 1. And so bump left, it was, okay. If it bumps left, then go to the right in the next state. I'll just keep going to the left. Asynchronous. Oh, right. And then okay, great success. It's 24 seconds. Okay, so this is the same as the last problem, except when ground is 0, the next cycle this asserts. But the FSM remain, I won't type it because we need to switch gears, but the FSM, it's like left or right, and it stays left or right, except, so when ground is 0, the FSM doesn't change at all. We just basically wait a cycle and then have it say ah. You could have like double the states if you want, but I don't think that's necessary. And then when the ground reappears, then in the next cycle, your FSM resumes, meaning you're just gonna continue where you left off. You walk left. And then if ground is 0, you ignore all inputs. Yeah, anyway, I'll work on this probably like tomorrow. And let's do another timer of 45 minutes. I will have a piece of dark chocolate on my time while reading this question, so my brain can keep going. So 2 strings, strings A and string B, returns short back. It's both okay. Okay. So what? This is a simple case because, and they made it tricky because this is one, like, this is index 0, so at the beginning, and then cab is like appending, so you can't just say, well, yeah, because this, you can say, now you need to return the shortest, right? So because you get, what if you delete like B? So I mean, I guess this is also valid, for example, but it's not the shortest. Sorry, A, like for example, A, C, A, B, A, BAC. Like for example, like this is fine, right? Like this is also like, or like AC, like BA, and then like BC is also like a legitimate one. But I guess if you want shortest, it behooves you not to just add a bunch of extra characters in. That's not necessary. So how do you even, let's say I have to do this by hand, how would I solve it? I guess I would say, what is the longest common subsequence between the two? Like for example, AB shows up here, and then, but you could also like AB also is AB here. So in this case, but then, so like, let's say I say, well, okay, these two matches, then why don't I just append C into this? But I guess the difficulty is like, well, why not this, right? How do you know? I mean, but then that won't satisfy the, this guy, right? I need this guy in there. So this is a DP problem, but obviously, but how do you even think about this? Suppose I have C, right? Let's say I just have one letter on the other one, on the shorter one, let's say, then it's just a matter of, well, if C's in this one, then we return this one, but suppose this, then it's not even in the subsequence at all, so add it anywhere you want. Add it here, it all works. So let's say just add it to the end. Now, what about cab, right? Is there anything that so I know this is the answer for C, right? um, the shortest answer for C. So if I add an A, I need to know that the tricky part is, suppose I have a C, then obviously I had to put the C here. Now here, I have an A, like, I can't just recursively say, like, it was a C here, because, like, I can't just say if A was in this previous answer, then shove it anywhere, right? Then just keep returning this, because then the order won't matter, but the order obviously matters. So it's actually like answer for C with previous inserted value as C. So given this, we know this, and the previous inserted thing is C, we need to compare it to A. Then here's the issue, like if I do A here, and then later on, I'll say, well, C, A was inserted, so find a subsequence of CA, and then add a B. Then you get this, but this is much longer than this. So I guess how do you formulate subproblems such that you can build the answer of the previous subproblem to the next one? In this case, this doesn't seem to quite work. Now, let's rewind a bit. Suppose there was no common subsequence that overlaps, then the best answer we get is just appending the two, obviously. In this case, we can visually inspect that the most common subsequence is AB. This is the hard part, but then even after we do that, we need to know so that's one hard problem. The second hard problem is I need to know what the indices are. So for example, like K, J, Q. I identify A and B on these two, then what do I do? Then I know, well, I get rid of these two characters and I need to shove these somewhere in here. And I also need to know that A and B correspond to these A and B's. So then I can slip it in the correct characters. Well, we start with the worst string. So for example, what if we just try to build the string from these two? Here it talks about deleting C. The inverse situation is like adding C to this. So wondering like if we can do maybe a table or something like that, and then we say and we make a decision to add A or C here at the first one, and if we added A, then the next one we must add B or C, or if we added C, then we must add A or A, right? Something like that. So first letter could be A or it could be C, and then it could be a B, a C, or just CA actually. Now if we do CA, we can also get rid of this. And I don't think that's too greedy because it's in order. Then so I guess you could have like a pointer here, and then here you already typed CA, so you have a pointer here. But suppose like that. Okay. Now you could do AX or AC, and here you could also do CA, which is just itself. Plus this. And then you just have like this. Left. And then so going on AX, we could do XB, XC, XA, XB also covers, well, yeah, we actually have XB or XC. Or AC means this and this, so you could do like ACX or ACA, which is the children of these. And then here we say basically CAX, and then let's say B, right? Let's just condense this and then say like this. Can we stop here? No, because if we're doing this search and let's say we find something optimal at this point, it could be not good enough because, for instance, if this was just cab instead of YAC, like this was cab, then you actually didn't need to add anything. Like this is within this. Okay. Let's try that solution again, where we start with C. C's in this, and then so we have where we added the C, now we have A, B, right? So the next letter is A. We have two choices here. And it seems like we could do, and then we've added CA. Or we could do so for example, this is generated from, so ignoring the C, and then we just add back CA, right? So this is saying, I actually want to add back everything. But now, so we could do this, meaning I match this and go here, and then we could also match this and go here. I feel like though, if you're going to do this sort of matching, so suppose I need to add A and then also C, like this is a candidate and then this is a candidate and then this is a candidate as well. But perhaps what we can do is say, if I match an A, I should match the furthest A to the right hand side or the later in the letter, because when I prepend the C, then I can just search backwards and say, well, is there any C? If there's any C, then I can go ahead and delete it. Like for example, if there's a C here and I match this, then I don't need to add a C. if I match here, then even if there's C here, I need to add a C here. So here I add, so maybe I could just do that. Does that generalize out though, and then say, well, why don't I just match B, which is here, and then if that matches, I go back to search for some A. So but then that's very biased backwards, because in the same way if this was cab versus like this, and then you're like, well, B is here, so why don't I just do A and C, right? Then obviously that's not good, because this is better. Now what happens if you do both passes? Or does that still leave a lot of holes, you know? So for example, I start here, but this is here, and then I need to add all this to here, but it's not necessary. Same thing here, if I started here, you know, it's kind of necessary. But anyway, going back, so this was the simple case I was considering where I just do 2 passes, but maybe not. So now we have candidates, this and this. And in this case, we have this as a candidate, and then if we try to do A with this reverse strategy, then we have given we've added C, so then this is a candidate. And this is CA. So I'm wondering, like, if we can prune either of these, right? This is 7 letters, this is 7 letter. How do we say which one's provably better than the other? Hard to say. This first character is like way far out here. This first character is here. So this is a better position than this one. But that seems like a bit informal, right? We could also say, well, the last character is here and then the last character is here. So any expansion has to take outside here, and any expansion can still be within this range. So maybe that's good. So suppose we use this last index strategy, and then we say this one's here, this one's here, so this is no longer a candidate. right? They're same length. So I just eliminate this. And then let's say I add an X. Because this is the last matching one. I can also just add this. And then I have a B left. So I know last index is, you know, this guy, 6. And then you can say B matches here. And then you do like and then you can also just say that, you know, this is my last index and just add it as close to last index as possible. So like this, and then you'd end up with the shorter one. But like, if you have a longer prefix, that just doesn't match. Like, you can also just say, oh, B's here and B's at the last index. And then also, like comparing this to this, then can I just say my candidate is this or this? Meaning I drop any like I just try to drop like any suffix intervals that I can, because then it allows me more room to match. And so basically be choosing between not adding anything or adding something. And we can prune if things are of the same length and my last position is better. So here we generate like, I guess recursively, A. And, you know, we try to match A here, we don't get it. A. This index is higher than this, but this is longer, so we don't know. And then we do X. But X is here, so now we can prune this. and so on. There's like another thing where it's like let's say this, and you can match this or you can prepend it, so then eventually you would have like this versus just this, but also like this is something of concern. Like, I guess what I'm trying to think of is like, is it always just gonna be I prepend it at index 0 and versus I just be greedy and find the first thing? Or is there a case where because of this being here, eventually this will do like these three, but when I'm here, I'll also have another, like, in parallel, like these three that have matched. So it's like for each character, like I can match or prepend to string. I'll just read the discussion actually, because I have no idea. Find the LCS, okay. What is LCS? These Oh, interesting. It's actually adding a character. Okay. So this is the longest common subsequence, and then, which I don't really know. I'll need to read up on this. And then once you have some longest common subsequence like cab or something like that, then for both of these characters, if this isn't in the common subsequence, which is in order, then you would just prepend the result in A, and then if I do find something in the subsequence, I break it and then I go to I see. So like for the first letter in the common subsequence, I'll just add a result in A and then add a result in B. And then this result will just scoop up all the A's and B's. That isn't the first letter in the subsequence, and I'll append the common subsequence. Because we break when when both of these matches, and both of these are guaranteed to match because they're longest common subsequence. And then for a second letter, we have these whatever gaps. Okay, I see. So then your result is just basically going to be all of your A and B stuff. So your result is just going to be your A and B's that are not in the longest common subsequence interleaved with your common longest common subsequence, and ergo these last indices are what you append. Okay, sure, that makes sense. Now for this part, I'll probably watch a YouTube video on it or something, because it seems like this is a fairly common problem. But it seems like you start out with some empty string. So you have n plus 1, n plus 1 instead of nm. And if this pairwise ij matches, then you map it back to the matrix to say that the previous letter plus this character, and if it doesn't match pairwise ij across strings A and B, then you take the maximum of character where your A is and the previous letter of B, comma, previous letter of A and current letter of B. Oh, you want the max because it's the longest subsequence. And I'm not familiar with this key equals length thing on max, but I guess because dp of ij is a string as opposed to a numerical value, I guess you can just say I put two arbitrary things in here and then compare against them the key. That's actually pretty neat, this thing. I'll probably try to implement this from memory, but probably not in the next 2 minutes. Also, I need to get better at these one-liners in Python. So max Python with key. So you can write like any function and then in your iterable just shove it into the function. It's like it could be like square root of 2. Okay, that's kind of cool. It's kind of a built-in lambda as your key. Okay, this is actually interesting. I think this is a common computer science problem, so I should probably study for it, but DP is definitely not a strength. I like yesterday's hard better because of the DFS. So I was right, it was like DP, but the DP doesn't solve. The DP is not the thing that solves this problem. The DP is the thing that massages this problem so you can build the string. Which, okay, fair enough. Alright, I'll probably do this on my own time. Yeah, so yeah, 45 minutes, 0 line of code, standard.